Looks like we're assembled here, so we'll get started. So again, we got the notebooks if you want to download those. And also, oh, I should have mentioned this. The notebook requires seaborn, which, as far as I can tell, at least when I tried, I uninstalled and reinstalled Anaconda distro. I didn't get seaborn. So I had to, from a command prompt, I had to run pip install seaborn to get that.
Conda also works.
Huh?
Conda install seaborn.
Yeah, you can also do Conda if you prefer. Either Conda or pip install will get you there, theoretically. So Ronald, do you want to stand up in the back? So some of this material was jointly prepared by me. I'm Steve Elston, and Ronald Lopez is in the back. And the way we're going to do this is I'm going to yak, and Ronald is here to help you guys if you get stuck on something or can't do it. I'm going to try to break this up into like 5 or 6 segments where I'll give you a little bit of an introduction. Then we've got some exercises prepared where you guys get to try something. And, we'll give you like a couple, 4 or 5 minutes to do the little exercise. And, so we'll go through it in little pieces like that. So hopefully it'll be more interesting and interactive. I mean, I find for me in tutorials or when I'm learning stuff, the only thing I remember like 2 weeks later is the stuff I did, not what somebody told me in a lecture. But maybe that's just me. I don't know. Do you want to say some introduction about yourself, Ronald? You're okay. All right. I can introduce Ronald too. So I'm principal consultant at a company called Quanti Analytics, a very small boutique data science consultancy. I teach and I also my moonlight job is I teach data science at the University of Washington, and I have some O'Reilly publications and have created some edX courses. And as you can tell, I've been around for a while doing data science since before it was called data science, back when we actually called it statistics. But, times change, got to keep up. And Ronald's a research analyst with the San Jose Evergreen Community College system, and he's also active with the California Institutional Research Board. And so enough about that. So let's get started with the actual material here. Actually, let me say a few more introductory things. So data set is one. If you guys are sort of new to data science or whatever, there's this pretty amazing University of California Irvine machine learning repository. Has lots of data sets. Some of them are really great. Some of them are like super weird. And that, or there's like the Kaggle site. There's a bunch of places you can grab data sets to just try stuff out, or if you're like me, teach stuff and you need some good examples. So one thing I'll mention about this data is you'll notice it's a little quaint in terms of automobile prices and even some automobile companies that I don't think exist anymore, but it's from 1985. So the data is a bit antique, but the methods we're going to use aren't, so that's good. And you can read all this, but to me, visualization is one of those core data science skills. There's a tendency that we all have to want to get in and see some numbers or build a model or do something like that. But honestly, if you haven't looked at the data, if you don't have a feel for what the columns are and how they relate, say, to your label, or what weirdness there might be in the relationship between them, maybe outliers, maybe features that are just completely collinear that don't really tell you anything, you really are missing the boat. So along with sort of cleanup and figuring out how your data works and modeling, you should be going back and forth and doing as much visualization as you can figure out. And it's all about having, real world data that you're going to do for money is is inherently complex. Like if it was easy, nobody would pay you to do it, right? So you need to create different views of the data, different ways to think about putting it together. And generally that means multiple, you'll do multiple different types of charts. You'll try different combinations of which variables go on those charts, things like that. And you get into this fundamental problem that, we're all looking at screens or whatever. So the projection surface we always visualize data on is two-dimensional. And that's a real limitation. We can't, maybe someday we'll have VR systems that we can walk through, 18 dimensions of data or something, but we're not there. Right now we're stuck in two-dimensional space. And a lot of what I'm going to show you here is how to best use that two-dimensional space, how to get the most information without, and a word of caution, which I'll repeat several times probably, is don't try to get too much onto that. I've been to some talks, in fact one lately by a speaker who I won't name a few weeks ago, who you absolutely could not, maybe he understood his charts, but you could see from the slack-jawed looks in the audience that nobody else had any idea about all the subtle differences in colors, symbols, dotted lines, I don't know what all he had going on there. And it was completely, inscrutable. So don't overdo it. There's ways around this. Sometimes it just means you got to look at a lot more plots or do some other things. Just a historic note, I'm not recommending anybody run out and read these books unless you're kind of interested in the history. So way back, go back to almost prehistoric times for data science. In the 1960s and early 70s, statistics, because there was no data science in those days, was all about models. And in fact, for me as an undergraduate in the 70s, we had to learn how to prove things about the central limit theorem or something. That was what a stats class was. You didn't actually look at data, as crazy as that seems, right? I mean, how can you do stats without data? But that's how it was done. And John W. Tukey, who was one of the truly great minds of data analysis ever, started saying, well, wait, guys, we got to look at the data. Don't just start building all these models and doing all this theory, but what is actually in the data? And he published a number of papers and kind of pulled it together in this really groundbreaking book, Exploratory Data Analysis, 1977. So that, to me, is sort of the T equals 0 time of exploratory data analysis when that book hit the shelves. So spool forward almost 20 years, and Bill Cleveland, who I had the privilege to work with when he was at Bell Labs, he started worrying about this problem I was just talking about. We only have two dimensions to project our data onto, and believe it or not, in those days, a lot of it had to do with actually pen plotting on paper. But regardless whether it's on a screen from a web page or plot it with actual ink on a paper, you still have this problem. You're projecting onto 2D surfaces. So Bill had been thinking deeply about this problem for 10, 15 years, and he published, again, another pioneering book called Visualizing Data in the early 90s. And so what's the outline of what we're going to do here? We're going to first off just go through, because this is a course, an introductory tutorial here. That's how we build it. So we're just going to talk about what are some basic plot types, and there's a lot more than we can cover. But at least I want to get everybody on the page where you've at least built a few basic plots. And look at, I should point out there's also, here, the resources. So there's this pandas visualization tutorial, a seaborn visualization tutorial, and then matplotlib also. And this one's has a lot, there's a lot of rich stuff here. There's videos, there's books and articles and some tutorials. There's a lot more you can do with this than we can cover in 90 minutes for sure. I mean, people spend literally careers researching visualization. So, all right, so the first thing we got to do is load the data set. And there's a couple of weirdnesses with this data, which is that the missing values were coded as a text question mark. And also that the numeric columns were coded as text. So we have to go through, find all the question marks, turn them to a NumPy, NaN, get rid of. You could do various things. We could interpolate, we could backfill. If you heard Kishore's talk, he went through that. There's only, I think, 10 of them out of about 205. So we're just going to remove those and not worry about the lost data at this point. And then we got to convert everything to numeric. So go ahead and run that cell. So if you don't know, you can just run a cell. You guys probably know that. But just click the run cell and hopefully it worked. Hopefully it won't take too long or die here. That would be bad. Not sure why it's taking so long. Anybody else having problems loading it, or is it okay? Okay? All right. Oh, okay, it worked. I guess it's just sleepy computer. And we can look at the head of the data frame just to get a feel for what's there. And this originally this data set had to do with insurance losses. That's why there's this symbolizing and normalized losses column, which we're largely going to ignore. But you can see there's like the make of the car, the fuel type, the aspiration, that is, whether it's standard or turbo, the number of doors, a bunch of common characteristics of cars, some characteristics of their engines, and their mileage, and then the price of the car. So just for point of exercise here, we're just going to focus on, though we were exploring to build a model so we could figure out the prices of cars. There can be real problems with this. For example, like there's the Zestimate for Zillow for real estate, right? Where they're trying to estimate the price of a house based on various characteristics. So this is kind of like the 1985 car version of that. So, and we can just look at some summary of some of the numeric columns and just get a feel for. There's a wide range of values here, from the wheelbase, the length. You see they're just different ranges of variables. So that's just, and you can look at that more if you want, but you can just get an idea of what and then the min, the max, the quartiles. So, and that's using, by the way, the pandas describe. So let's get started with some plots. So to me, the plot that I use most, that's kind of a fundamental plot, is the scatter plot. And we'll do a line plot, and then some more plots where we look at sort of distributions, bar plots, histograms, box plots, kernel density estimation, and violin plots. So there's lots of plots for that. So a scatter plot, pretty much, I'm sure you're familiar with that. You're plotting X against Y. You're looking at the distribution. Oh, one thing, if you are running in a notebook or any kind of IPython environment, and you want stuff to display in line, you need this magic command, matplotlib inline, with the %, or else stuff will either not display or display in another window or something like that. So we're just going to make a really simple. So the way this works, so we have a pandas data frame here called auto underbar prices, okay? And then I've got a plot method on that, and I can say what kind of plot I want, scatter. In this case, there's a whole bunch of, and if you look at that tutorial that I have a reference to earlier, you'll see where that is. And I'm just going to do city miles per gallon against price, okay? And there you have it. And you can see it's not really a linear relationship. It's pretty curvy, and there's some other points out here. So already and then there's this cluster of kind of high-priced, low fuel efficiency cars here, and a cluster of pretty cheap, remarkably high fuel efficiency cars over there. So already we're seeing some curious aspects of this data set. Maybe we can figure out what all that's about. And in here, if you go back and look at the notebook later, I've kind of given you the recipe for how I do stuff. So the next thing is we're going to use matplotlib. So I'm going to import matplotlib.pyplot as PLT, and I'm going to define a figure of a certain size, 10 by 10, and I'm going to define just one axis at this point within that figure. You see how that works? And so now we can plot that, make that same plot, but we do it assigning an axis, set of axes, and also we can now assign attributes. See, I've got ax.setTitle, so I give it a main title, label, etc. Now to me, and maybe it's because I also teach data science, a plot without proper labels is utterly useless. And honestly, if you're going to, another reason to learn visualization is, as data scientists, we want to have impact. We want people to pay attention to our results. We want people to take action on our results. That's where we deliver value. And if you go to a management presentation and show a bunch of plots with no axis labels and no titles, executive time, attention span is going to make a 2-year-old look like a laser focus, so you're doomed. So always make sure you have good axis labels. And there's nothing new on this plot. It's just, you can see I made it bigger so we can kind of see it better. Well, maybe you guys can because I blew up my screen. So, and we've got proper labels. But I did that by using this, by creating an axis that I could assign attributes to. So that's the key point here. And then a line plot, as you can imagine, is pretty similar. So first off, I'm just going to create a new data frame where we have an x-axis and a y variable that's just the square. So it's just going to be 100 points on the x and the y. And we're just going to create a data frame for those using the pandas.dataframe method, okay? And then, again, using that same recipe, we can now plot. But notice I don't have to say what kind is, because pandas plotting, the default kind is a line. That's the default method. If it doesn't know any better, it'll make a line plot. So if you get, sometimes you get really kooky results because you forgot to say the kind. If you see something that looks like a bunch of worms having a wrestling match or something, it's probably because you forgot to say the kind you really wanted. So let me run that. And there's nothing too surprising here, right? It's just a plot of half a parabola, as you'd expect. Okay, so now it's your turn. So you've seen a couple of examples. So try to plot engine size against price. We looked at cities miles per gallon against price. Try to make the figure 8 by 8 instead of 10 by 10, and make sure you give your figure a meaningful title and axis labels, okay? So we'll give you guys just a couple, like 3 minutes. That's pretty easy. So we'll give you like 3 minutes to do that, okay? And raise your hand if you feel like you're not quite there or some problem. And you're welcome to work, with the people next to you or whatever. Oh, I suppose everybody knows, right? To make a new cell below there, you just insert a cell below, like that. So you can have a cell that you can cut and you can just cut and paste some of my code in there and edit it, and then just run it with this run here. So I should have said that before. Sorry. It's at a, do you have it, Ronald? Ronald will help you.
I found it in Github, but how do I run
Do you not have? Do you have Jupyter installed?
Oh, do I need that?
Huh?
I did Jupyter.
Well, if you installed did you install Anaconda?
Yeah, I did.
Okay, well you should be able to. So go to where you have Anaconda and look for Jupyter.
I believe. It's been a while since I've Oh, it must have been on a different machine.
Oh.
I don't think I have a Hanukkah.
Well, yeah, so go ahead and stream if you want to install it on that machine, or if you just want to follow on the GitHub, you'll see there's also just a static HTML or work with some other people at your table here. So, yeah, if you don't have Anaconda and Jupyter installed, it's nice. It'll work.
Yeah, I installed that seaborn.
Yeah.
Successfully. How do I get to it?
It should just, when you start Jupyter, if you start, it should just be there, right, when you start, like, do import seaborn as SNS or
I've been
something.
downloading like
should just-
extra packages.
Oh,
So
because if I started
I don't know.
Jupyter first, it would be.
Oh, yeah, no, you want to, right, probably not, because you probably started the kernel where it didn't. I don't know, because it just puts it in the directory. It might, I don't try it. I'm not sure.
Every launch.
Right, if you go to download it,
Relaunching may be the safe bet.
and then you got the
All right, success, failure, somewhere in between. Still working? All right. Well, you guys can get back to that later. We have to push on here. So we're going to start talking about plots that, where you look at a distribution of something. And kind of the granddaddy of all those is the bar plot. So the bar plot has counts on the vertical axis and categories on the horizontal axis. And but the thing is, if you're using pandas plotting, you have to have counts, right? The plotting method itself doesn't know how to make those counts. So that's a common mistake where you try to make a bar plot out of some categorical variable and you get some, long trace back of all sorts of errors that seem cryptic and that. So basically you wind up, or the way you can do it that's pretty easy is I'm just going to make a new data frame. And I'm going to do this for the make, which is like the manufacturer of the car. So I'm just going to do one column, and Pandas has a value under bar counts method. So let me just run that, and you'll see. So there. So it's a data frame. It has an so notice that the make now is the index of the data frame. It's not a column. That's the index. And then it only has one actual column of data, which is the count. So you can see like there's 32 Toyotas, 18 Nissans, and then down to 1 Mercury. All right? So that's the important sort of trick to know to make a bar plot. Everything else is pretty much, so this is the same recipe we used before, except notice I've got counts.plot.bar. Now I could have done counts.plot and then kind equals bar. You can do it either way. I decided to show you guys both ways, not to confuse you, just to show you that it most of the time works either way. So I'm going to go ahead and do this here. And you can see, here we got Toyota. Oh, notice the one cool thing. When it does counts, the default is to give you an ordered list from the largest to the smallest, which is nice because when I go to make, you often want to see that in a bar plot. You got Toyota, Nissan, et cetera, down to 1 Mercury car. So you see the most important or the most numerous, I don't know, maybe it's not the most important depending on your analysis, but at least the most numerous type. But you could do something, we could sort this. We could sort this by the index of that new data frame we created. And, maybe we want to do it by alphabetical, or maybe we have something even more complicated where we want to do it by is it a European manufacturer, a North American manufacturer, an Asian manufacturer? I mean, whatever makes sense, right? But just as a default, it's nice that it comes out from largest to smallest. Now, a histogram is virtually the same idea, except it's for a continuous variable. So notice this is a categorical variable. Toyota isn't a larger or smaller number than a Nissan or a Honda or whatever. It's just a category. So, but if we have numeric variable, like in this case engine size, a histogram is like a bar plot, except it has a range of numeric values that are equally spaced. And you can, I didn't do it here, but if you look at the arguments, if you do, like the help pages are really good for these things. If you look at pandas, if you use your favorite search engine, pandas.dataframe.plot.hist or something like that, you'll find that method and you'll see, yeah, you can set the number of bins and things like that. There's a bunch of arguments. So this, and again, got my titles and axis labels. So let me just do that. And I'm just taking all the defaults in this case. We'll get to doing fancier things with a histogram here in a bit. But so we can see it's actually kind of interesting. Notice that the average car of 1985, these are in cubic inches. That's obviously because this is an American data set, so it uses non-metric units. But you can see there's a heavy skew that cars tend to have much smaller engines, and there's a few cars with really tiny engines, and a few cars that are way out here with these ginormous engines. So we've already learned, just by looking at this histogram of engine size, we can see there's kind of some interesting stuff going on just with the engine size of these cars. Another way you can look at sort of relative frequency or size is with a box plot. So I mentioned Tukey in his 1977 book at the beginning of the talk here. So this is a plot that Tukey came up with in 1970. So it's been around for a while. And the nice thing about that is you can do two, like we'll do engine size again, but I've got another column here, fuel type. So you can do by equals fuel type. So that's like if you're used to SQL, that's the same as a group by operation in SQL, just that by. And the rest of this is just following our same recipe. There's nothing, I haven't slipped in anything new there just yet. We'll get there. And you can see, if you look at my axis labels, I got fuel type. So I have diesel cars, I've grouped all the diesel cars, and I've grouped all the gas or gasoline cars. And you can see the range of engine sizes here. So how do you read a box plot? So the red bar, it depends on what plotting system you're using. Pandas plots, it's a red bar. Sometimes it's a dark, thick bar. Whatever the bar is in the middle of the box, however that's displayed, that's the median value of that. So you can see the median diesel engine is somewhat larger than the median gasoline engine. But then the upper inner quartile and the lower inner quartile are what make up the box above and below that bar. So the inner quartile range, which is these two inner quartiles, is just that whole box. And so if I give this an eyeball, I would say, yeah, it does look like generally diesel engine cars have slightly larger engine displacements than gasoline cars, but also I would look and say, well, yeah, but the inner quartile range overlaps so much that I'm not sure that's a significant difference. Maybe it really doesn't matter. Maybe it's just a fluke of a few cars having bigger engines or something. Clearly there's a bit of skew too with diesels. You see that there's kind of the inner quartile range, upper and lower look about the same here, but notice how it's more compressed for diesels. So, well, we'll press on. Maybe we'll find something else. Okay, so I hope everybody was able to install Seaborn. And in the notebook, I give you guys, I just repeat that direction. What was the verdict on people who did you restart to get it to go with Jupyter, or did it
I relaunched it, but it still didn't.
still didn't work? Oh. Has anybody else tried to load Seaborn, or? Well, we'll see if this works for you guys. So, so Seaborn is the other plotting package, which I hope you guys can run. It's going to be a bit of a problem if there's some glitch here. Do you have any idea, Ronald, why some people are having trouble getting it to start in their Jupyter? Huh?
We had to create a virtual environment to get it to work.
Oh, you had to create on a Mac. You had to do a virtual environment. Oh, I'm not one of the cool kids. I don't have a Mac, so I don't know.
I think I initially installed it with pip and then I didn't work it.
So it worked better with Conda for you than pip?
Yeah, because I realized my IPython was actually Conda installed. And I go back and forth between.
Oh, okay.
Conda, so-
Oh, so okay. So she's saying if she had installed IPython with Conda and installed Seaborn then with Conda rather than pip, and that worked better. I had installed, well, on Windows I had installed Anaconda, the whole Anaconda stack with Conda, and then used pip, and that worked fine too. So, uh-oh. Yeah, I wish the Anaconda, I don't know if anybody's from Continuum here, but it would be really nice if they put this package. I don't know why. Maybe it's just something that they haven't gotten to yet, but it's newer. It's kind of the newer. Some of the newer, cooler plots are in Seaborn, which is why we're trying to use it. Hopefully, we can use it. So, the basics of Seaborn are you can set like a style, which is kind of the background that you're going to plot against. And in this case, I just picked the simplest one, like white grid. It's just a white background with some grid lines on it. And there's lots of arguments you can do. And we have a reference up at the beginning of the notebook to the Seaborn. Seaborn has some pretty nice tutorial examples you can go through. So it's pretty well documented. We have discovered, it's because it's a newer package, not everything works consistently quite the way you would think. So there's sometimes you think there should be an argument, and there isn't, or it doesn't quite work, or something like that. So it's not as bulletproof as some of the older Python plotting stuff, but it's worth messing with just because it's got some nice facilities. Like in this case, so I'm going to do what's a kernel density estimation plot, KDE plot, for the engine size. Hopefully other people can do this too. Anybody having any luck, or is it just some luck? Okay, a few positive responses, okay. Anybody like just crashing and burning completely on this? No. Okay. So, okay, well, it seems like we've gotten over that hurdle. I was a little worried about that, introducing Seaborn into a tutorial like this where it's a thing that you have to install on the fly and hope it works. So what's the idea? So we looked at, box plots. We looked at the histogram. So the kernel density estimation plot is basically, it's a local regression that's a nonlinear regression. And so, like let's just go back and refresh our minds on the histogram. So remember the histogram was pretty skewed to the left, and then we had these outliers out here for really big engine displacement cars. And so a smoothed regression view of that, you can see, yeah, that looks right. See, it's pretty skewed to the left. And then you got some little humps out here, which are these cars with anomalously large engine displacement. So it's a very nice way to present a smoother view than a histogram. And honestly, it depends what you're doing. You can't say KDE plots are better than histograms or vice versa. It's like, well, what are you trying to show? Why are you trying to show it? It's just another tool in your box when you're doing this. So we can also then extend the recipe just as we did with the pandas plotting, we can define a figure. Again, we're using, this is matplotlib.pyplot, so, which we loaded earlier. So define a figure, define our axis here. Again, just set our white grid background, and the new thing is here we got AX equals AX. So we're plotting this seaborn plot now on this figure with this axis that we've defined. And because we've defined which axis set of axes, I should say, we're doing this on, I can use like ax.set title, ax.set x label, y label, etc., just as I did for the pandas plot. And let me run that. And so just as advertised, I get a bigger plot. I have my title. I have my axes labels. I will warn you, not every seaborn plotting method will take AX as an argument. I don't know why. It's a little annoying inconsistency. It's probably just people haven't gotten to it. You know, there's only so many contributors doing so much, and they probably all have day jobs. So, but this one, you know, for most plot types, it works really well. As you can see, we've got a pretty nice plot with nice labels and all that. Okay? And then another plot. What was the point of this one? Oh, so we can do a two-dimensional KDE plot. That is one of the advantages. Like the one-dimensional plot and the histogram are often interchangeable. They may or may not show you any additional information. But there's no, I mean, people, like, if you look at the icky graphics in Excel, you'll see they try to do a two-dimensional histogram, but I find them quite, at best, inscrutable and at worst, misleading. But if you do a two-dimensional KDE plot, see, I can do engine size versus price, because I have a two-dimensional surface, right? So everything else is, oh, and the C map is just the color map that I'm using. We'll talk about palettes a little bit in a bit here. So, but the big change here is, oh, and if you're new to pandas, notice that it's a list within so the square brackets, the outer square brackets here are the subset operator in pandas. The inner square brackets are defining a Python list. So you got to have, if you're doing several columns that you're subsetting from pandas by name, you got to have both sets of brackets, and they're not redundant. They're not doing the same thing at all. And there we've got it. Oops. There we go. So you see it's kind of a contour plot of density. And so that's interesting now. We've learned something new. Remember we had seen the skew that most cars had pretty small engine sizes, but we also see that most cars are actually on the inexpensive end of the spectrum. Because remember, there's 1985 prices, so I don't think there's any new cars you could get nowadays that are around $8,000. Maybe a bicycle, but anyway, so you can see that there's a distinct skew in the whole data set toward inexpensive cars with small engines.
So is there a way to make it tighter, like the grid to the 2D plot? Do you see that there's a lot of empty space?
So the question is there a way to like not have all this white space? I don't think so, because there actually are cars out here. It's just that they're so low density that they're below that lowest contour. There may be an option, actually, I'd have to research it.
You can manually change the X, Y limits.
Yeah, that's true. You can set X, Y limits when you set up the axes. The other thing I was going to say is I think there's an argument to the KDE plot where for the 2D, you can actually say to show the outliers that are below that lowest contour level. Or you could just, you could actually lay another plot on top of this. You can layer plots, right? So you could layer onto that same axis an XY scatter plot of the outlier cars. So either way, like he said, you can manually set the x-axis and y-axis limits. That's not too hard. Or if it was me, I guess I'd try to actually show where are those outlier cars, because there are cars out there. They're just below that lowest contour line? But that's a great question. So finally, a plot that isn't used a lot, but I actually think is very cool, is a violin plot. And there's nothing new again in our recipe here. We're just going to do, it's kind of like the box plot in terms of arguments. We're going to do x, and x in this case is going to be like a group by, and y is engine size, which is the same thing, recall, we did with the box plots when we did the side-by-side box plots. And everything else is pretty much what I just showed you. And so what's a violin plot? You can see this one almost does, well, maybe it looks more like a mandolin, but it kind of looks like a violin, I guess. This one looks like a broken violin. But the point is, it's like it combines some of the nice features of a histogram with some of the nice features of a box plot. And you can see the median is shown as a dot here. The interquartile range is shown as this black bar. So there's all the attributes of a box plot. But then there's like, I should have said not a histogram, a KDE plot. Then here's the smooth density curves. And now you start seeing some real differences between diesel and gasoline cars. All these big engine cars that are sort of our outliers all turn out to be gasoline. There are no, really huge diesel engines here. The diesel are in a pretty tight range, and they're actually fairly uniformly distributed compared to the gasoline cars. So just by doing this different view with a different kind of plot, we've just learned two really interesting things. So I think, okay. So now we're going to talk about aesthetics. So a plot aesthetics can be, aesthetic sounds like something that's just optional, it makes it look pretty, and yeah, you can do that. And you see that in a lot of awful looking business graphics where people use colors for no reason just because they think that it makes their PowerPoint look pretty or something. But aesthetics also can bring forth important information because, as you've seen, we haven't managed to display in any of these plots so far more than 2 dimensions of data, right? Because we're stuck on a 2-dimensional surface, as I said before. So how do we start getting more dimensions? Well, we could use aesthetics. We can use color. Transparency, you can't. Transparency, I'll show you why you should worry about that. We could use marker size and marker shape. And there's a lot of, almost every plot type has plot-specific aesthetics that are, I'll just show a few examples. It's like innumerable possible things. But let's look at color. So typically with color, you can see we're going to do a plot here, SNS, so it's again a seaborn plot, SNS.lm plot. LM plot, if you don't have this, well, it's off my scale here, but maybe I can scroll over. No. Okay, well, trying to make this big for you guys. Anyway, there's a thing about not to show the regression. No, the default is to show a regression line, which can be useful, right? I chose in this case to set that to false, which you guys can see, I hope, on your versions, but I can't see. I also picked this palette, because the default palette, you can try it without that palette argument. You'll see it's a shade of blue and green that are almost identical. That's the default. I couldn't, at least on my computer, I could hardly tell the difference without really squinting. So we're going to do city miles per gallon versus price, and we're going to do fuel type as what's called the hue argument. So again, hue is like a group by argument, and then it takes 2 colors from the palette and displays them. Okay, so we'll be able to see gasoline and diesel cars, and because I picked this optional palette. And if you look at the seaborn tutorials, you'll see there's a whole section on different, like they give you examples of all the palettes they supply, and then there's like a whole other section if you want to be hardcore and build your own palettes for some special purpose. It's an extensible palette system, which is cool, but it's going to be a lot of work. You better have a good reason before you commit the time on that. I generally haven't ever found that need, but maybe. So remember when we looked at this, we had this group of cars up here, we had this group of cars down here, and we had some kind of cars that were out by themselves away from this main group or cluster. Well, it turns out these, now you can see very clearly, these cars are the diesel cars. And they tend to be more expensive for a given fuel efficiency. So by adding this third dimension to my plot, by using a plot aesthetic, I've brought forth an interesting relationship here that for the amount of fuel efficiency I get, I have to spend more to get the equivalent diesel car. And I suppose if the Volkswagen, if we potted, I don't know what, emissions or something, it would be off the chart too, but that's another story. So now we're going to get into something a little more complicated. How do you take control of a lot of these aesthetics? And this gets to be difficult because there's limitations in like seaborn. For example, you can't change the marker shape and the marker color independently. Maybe like I said, maybe someday they'll get to that. But if you can, I've never figured it out, and I've tried. So this is a fair amount of code here. I'm sorry, but you can see it's just my imports. Oh, patches is to make like a legend. Okay. So there's a matplotlib.patches, which is a general purpose legend if you have like swatches of color, so literally patches of color. And so what I'm going to do is I'm going to, again, define a figure and define an axis, and I'm going to do just manually a group by. You could do it, you could use group by. I'm just, because we only have two classes here, I'm just going to do it with inline code, either gas or diesel. And when you do these group bys, Pandas plotting does some very user hostile things if you give it a empty data frame. So I always check before I plot it that the shape, that the row dimension of the shape, the 0 dimension, is greater than 0. Even if it's 1, it works, but if it's 0, it's bad news. And then, so I've set, I pick a column, I have the X, I have the Y, the X, and I'm going to make it dark blue and red. And then you can see that all this code is building the patches. Patches is handed through the handles as a list. So I have a red patch and a blue patch because I have red and blue colors here. So I'm just going to run all that. And so far I've created a plot that looks like what I did here with a whole lot less work, right? I mean, a whole lot more work to get essentially a plot that hasn't shown me anything more. But as we go, you'll see and add more aesthetics. But you see, there's a problem here. Notice at certain mileages and at certain price ranges, like at 19 miles per gallon and 24, 26, 20, look at how many dots are piled on top of each other. And we call this overplotting. And you can't, I feel like we missed an exercise. Oh well. You can't really tell how many cars are in that pile up, so to speak, right? So transparency doesn't really add another dimension, but it lets us look through. And it's pretty easy to add. There's just an alpha argument. And that's true of almost all Pandas plotting, matplot, base matplotlib, Pandas plotting, seaborn, whatever. The argument is called alpha. So 0.3 means 0 transparency. It's actually see-through. So 0 means it's invisible, right? There has no color at all. 1 is the default. That's totally opaque dot. So 0.3 is about 3/10 of the way from transparent. So that's the only change in this code. And if I scroll down here, oh, by the way, here's my patches. I don't know if I showed you that before. And now I can start to see, you can see, there's some overplotted points here and some single. you know, you get a better feel for like pretty high density in certain places like here, where there's just a lot of cars with similar characteristics on this plot. In other places, not so much. They're just sort of happen to line up. Okay, so here's an exercise for you guys. Create a new code cell, you know, just insert a cell below, copy the code from above, and change the color choice. And also we're going to do engine size versus curb weight. So we're going to change that list of columns we subset and see what you come up with, okay? And I'm going to go ahead and do it here too, because I got this. Oops. And if anybody's like stuck, wave and Ronald can help you. Let's see if I remember. I'm just going to call mine auto color 2 so I don't overwrite my function. Oh, I'm sorry, I meant to say, yeah. So you can see there's a for loop here. I forgot to mention that. So that for loop lets you loop over a list of columns. So you'll get a couple of plots, just one on top of, you know, one after the other. So you just replace this loop list with that. And then, I don't know. Let's see, did I succeed? What else? Did I do this? If you're getting stuck, raise your hand and Ronald can help you. Okay, I think I did it. Let's see what happens. Yeah, okay. Good.
I noticed that the VR stickers in your computer, and so I'm just wondering, so in our ecosystem we have jitter to deal with a little bit with this problem. So there's some perturbation.
You can jitter.
Is it? Oh, there it is.
Actually, look at, yeah, like seaborn. Seaborn has some nice jitter stuff built in. Actually, I think a lot of seaborn, they were trying to reproduce some of the more advanced features of our graphics. And it works in many cases. I'm not sure it works in every case it would in our.
Yeah, but just knowing that that's the analogy is kind of helpful to.
Oh, okay. Well, maybe I should mention that to other people know that are involved. All right, so it looks like a number of you are finished and some are still working, but you'll have time to do this later as well. Just to stick to our 90-minute time frame here, we got to move on. Since I'm also chairing this session, I suppose I get demerits if I run too far over. So here's my solution. All I did was I changed what was dark blue to green, and I changed it on the patch, and I just put this list of columns here. So it really wasn't that many things. Of course, you know, I have the advantage, I wrote the code, so I know I know what's where. I didn't have to reverse engineer what I was doing. But what I want to call the reason I wanted you guys to do this partly is you start to see from different views different aspects of the data set. And this is true of any data set. So, but in this particular case, like if we look at engine size versus price, it's not too actually surprising. You know, cars with big engines tend to be big cars that cost more, right? So it's pretty linear relationship there, honestly, right? Except for we got a few odd outliers at the low end, and at the high end, which we don't know about. But generally, yeah, you pay more for bigger engines. And notice the diesel are kind of all just in there, right? So it doesn't look like how much you pay for the size of the engine matters between gasoline and diesel. So that's interesting. Now, if we look at this is price versus curb weight, we start to get some odd things. We've got generally heavy cars cost more. I mean, probably makes more sense. There's just more materials, probably more labor, etc. But we've got a couple of very costly lightweight cars here. So that's interesting. We've got and even if you sort of think about what the straight line is, we've got, again, even for heavy cars, there's some what seem like anomalously expensive cars out here. So we could continue to investigate that. You know, we could subset our pandas data frame for cars with a price over 30,000, maybe just look at, you know, what are those cars? What's special about them? And then, you know, same thing down here, maybe for extremely light cars, we can just look at them, see what they are. So, okay, so one of the reasons to go through all this extra code is, as I said, you can't separate marker, at least maybe somebody will come and show me. Oh, I wanted to mention something, sorry. So there was a question while you guys were working on the exercise about the relationship between some of the plots I'm showing here and plots in R. So if you don't know anything about R plotting, this isn't going to help you, but part of what they're trying to do with seaborn is bring into the pandas or into the Python world some of the more cutting edge plotting methods in R, like the violin plots and stuff like that. So if you know a bit about R plotting, maybe that helps you think about it. If you don't know anything about R plotting, ignore that I just said that, so because it isn't going to help you or hurt you. So let's add a marker size. So there's this S argument in the pandas data frame, and one of the things you got to think about. So we're going to make the marker size. We're going to set it by the engine size of the car. Okay, we're going to add another dimension to our plot. So we're actually going to have 4 dimensions here. We're going to have whatever the column is, city miles per gallon this place, the price, that's 2. Then we're going to have the color for gas or diesel, that's 3. And we're going to have the marker size be a 4th dimension. So we're going to have 4 dimensions on this plot. And notice I had to scale this a little bit, like by 0.5. And alpha, as you'll see, having the alpha set fairly low when you do larger markers is often very important, because by having big markers, you're tending to get more overplotting. So here we go. And so you can see some diesel, it doesn't, you can see a couple cars here with bigger engines, smaller engines. I stared at this, it's surprisingly a larger engine and a smaller engine. The biggest engines tend to be up here, I think, in these expensive, low efficiency cars, which, shouldn't be too surprising. But notice there's an issue here. This is the engine size here is plotted as the diameter or radius or whatever of the marker, right? And that's it. Our eyes, I think, and there's been research on this, the human eye isn't that good at noticing that small differences in diameter. You got to kind of really look and say, oh yeah, that engine is a little smaller than that engine, right? But it's not so great. So another way to do this is what I've done here, where, it's off the screen here, but I basically squared it. So I'm going by the, so now the area of my marker is proportional to engine size rather than the radius or whatever, okay? And so let me run that. And you can see, yeah, look, that was that relationship you could hardly see before, but you can see, yeah, this car definitely has an engine that's quite a bit bigger than that car, for example. With using an area marker size as opposed to a size marker size is often a really powerful technique to keep in mind. And there's a lot of research that's been done on the human perception issues of these kind of things, what's misleading. By the way, you'll notice in my presentation there are no pie charts. Tukey, who I keep talking about, had if you read that 1977 book, he doesn't talk about pie charts. He has one little footnote basically that says, pie charts are an excellent tool for obfuscating the relationships in your data. So basically, if you're trying to fool people, use lots of pie charts. If you're trying to elucidate and illuminate your observations, don't use pie charts. So another thing we can do now, so let's bring a fifth dimension onto this plot. And we're going to use marker shape. And so this gets a little complicated, the code here, I'm sorry. So I built 4 lists because I'm going to do 4 subsets. So I'm going to have aspiration of turbo and diesel, turbo and gas, standard and diesel, standard and gas. So those are my 4 possible combinations of, how the carburation and the fuel type, right? And then I'm going to use a dot, an O for turbo and a plus for standard. And then I'm going to use red for diesel. So you see diesel is red, dark blue for gas, diesel is red, dark blue for gas. I hope that's clear. this is just setting it up, but you have to somehow define all this stuff, so I just did it as 4 lists. And again, we're going to just do it on one axis here. And then I just use a zip. You guys know about zip, I hope. So I just zip all 4 of those lists together, and in my for loop, I get, an element from each of those 4 lists that I can use down here to lay, basically I'm laying 4 layers on top of that plot. The first being, the turbo diesel, then the turbo gas, etc. So a little tricky, but not too bad if you think about it. So let me run that code. Hopefully it's not too mind-boggling. All right, so now we've got a 5-dimensional plot on our 2-dimensional surface. We've got price on the vertical, city miles per gallon on the horizontal. We've got gas in blue, turbo or diesel in red, and then we've got standard aspiration with pluses and turbo cars in circles. So you can see, for example, all our big outlier cars here are gas standard aspiration cars. And they all have big engine sizes for the most part. So that's why they're expensive and why they are gas fuel guzzlers, basically, right? Notice that most of our diesels are turbo. See, most of the red on here is circles, very few non-turbo diesels. And we do have some odd things like the big gas engine down here that's yet very fuel efficient and things like that. But, which we'd have to investigate further. Those seem to be just odd relationships. But, so I hope you guys see now it's a bit of code, admittedly, but, we've gotten 5 dimensions onto this plot and we've learned some interesting stuff by doing that, okay? And so some plot-specific aesthetics. The simplest one is like histograms, how many bins. So I'm just going to make, and so the only new thing you got to know here is notice how I did plot.subplots 1, 2, and a figure size. So that means 1 row, 2 columns. So I'm creating a little array of axes. So you see how I have axis 0, axis 1 down here? So let me just run that. And the only point of this is, the default was 10. We saw that before. If I use 40, it looks a lot jaggedier, but I can see there's really just 3 cars out here in this really big engine category. Or there's really just 2 cars in these outliers of low engine size. So there's quite, but again, it depends what you're trying to present, what you're trying to look at. Whether, there's no saying that more bins are better. It's just different. And we can do a similar thing with violin plots going back to seaborn. So we have a hue parameter and we're going to make that aspiration. Remember we did auto price and fuel type to do 2 side-by-side violin plots before. So now I've added hue. And I'm also going to split. I have this split argument set. And so now you see, if I scroll correctly, you'll see, So you'll see gas cars that are turbo and standard, and diesel cars that are turbo and standard. So you start to see there's real differences in the price distributions of these cars. So we've got 3 dimensions on this surface here, because we have fuel type, aspiration, and price. So, and you can do similar things with box plots in, so notice I got the gas and the diesel. I did this by body style, so you can see hard tops have this really wide price range, and almost all hard tops are gas. I think that might be one hard top that's diesel. You kind of have to investigate. These ones that are just a single bar don't look like anything. Okay, so another exercise. We'll do this hopefully really quick because I want to get on to multi-axis plots before we run out of time. So do another code cell and just change it's really just changing that violin plot and looking, instead of where we did, let's see, which gas and diesel we're going to do drive wheel. So it's like rear wheel drive, front wheel drive, 4-wheel drive, okay? So try that for just a couple minutes. Hopefully you're still with me. We'll see. Good. Harder than it looks. Let's see if I do this correctly. So there's really just one thing you have to change for this exercise. It's very quick. So with luck, y'all should be getting something like this, more or less. Gee, it's a pretty shaky podium here. Okay, it looks like a number of people seem to be done. So really all you had to do was change this X variable to drive wheels, because you're just trying to put the type of drive wheel, which is a categorical variable, on this X-axis. And you can see, yeah, there's significant difference between standard and turbo aspiration for rear-wheel drive, front-wheel drive, four-wheel drive. For example, our cheapest cars are all standard aspiration front-wheel drive cars. Yeah, that kind of makes sense, right? I mean, your small, light, inexpensive cars tend to be front-wheel drive cars. Your outliers in terms of really expensive cars tend to be, again, these gasoline standard aspiration cars. So, you know, if you know even a tiny bit about cars, that all makes sense. All right, so sorry, I gotta move on here, but so another thing we're gonna look at now, so we've basically been dealing with one axis with one exception. In your exercise way up here, you created two axes, one after the other, but you didn't plot on them. But let's look at what we can do if we do different axes on a single figure. So this is another way to add extra dimensions to a visualization. It's a very important thing. And I mentioned the book by Bill Cleveland at the beginning. So this was a lot of the thinking behind this in the 80s and early 90s was done by Bill Cleveland, to think about how do we come up with ways to use multiple axes on a plot figure to show additional dimensions and show additional information. So, so a simple one, oops, let me go back up here. So we can just do, so like there's three types I'd like to get through here, or four types. So there's a pair plot, there's pairwise scatter plots, multi-axis plots, and faceted grids. So try to get through this. So there's a thing called a joint plot in Seaborn. And let me just show you what it is. So we've got two dimensions defined here, engine size and price, and our data is auto prices. So what does that look like? It's actually kind of cool. So and you can do other things. I think you can add a hue to this as well. But basically we have our price versus engine size, and you see the densities in terms of histograms on the margins of the plot, right? So I don't think there's anything here we haven't noticed with another plot type, but it's another way to display. And if you had many pairwise combinations to go through, it could be a cool way to do it. But there's also a pairwise scatter plot capability called pair plot in Seaborn. So I'm just going to do the numeric columns. You can include, or certain numeric columns. You can include categorical variables, but they'll just show up as lines of dots, you know, horizontally, vertically, whatever. And, oh, well, you guys can't see. Well, maybe I can do this here. Yeah, okay. So I have auto prices. I just subset by this list of numeric columns. I'm going to set the hue to fuel type, which is what we've been doing, my same palette. And then I can say on the diagonal, I'm going to do a kernel density plot. And then on the upper, see there's also this method map.upper, I'm going to do a kernel density plot as well. And I'm going to again use that blues underbar D palette. So this is going to take a while to compute this. It's just going to grind away. By the way, depending on versions and things like that, Ronald doesn't get this. I do. This warning, it's coming, I think it's actually maybe a bug in a newer version of NumPy, that things that are integers, somehow it doesn't think they're integers or something. It doesn't seem to hurt anything, but it's a bit annoying. Okay, so there's a lot going on here. So you see the general idea of a pairwise scatter plot is we've got like price versus length, price versus curb weight, price versus engine size, horsepower, city. And then you can see, because we've got turbo and standard, so here's the two density plots, the KDEs of price for the two kinds of cars. And you can see, you know, you can look at like curb weight versus length. And, you know, not too surprisingly, long cars tend to be heavy because they're big, right? And then this is the two-dimensional KDE. So again, you can see length and curb weight. You can, you know, it's the same relationship. But you can see there's actually two centroids where cars tend to be light, short cars or long, heavy cars. There's kind of a gap in between those two big bumps. You know, who knows why? It's just maybe how car manufacturers do it. And you can see this is a relationship we looked at before of, oh, wait a minute, which one was I going to show you? It was the, let's see, I was looking for price and engine size. Well, you can see it here, like horsepower and price. Let's just go with that one. And there was this question about, you can see the default here is to show those outliers that are beyond where the lowest contour is. You can see the little green dots there. So again, most of our cars tend to be cheap, low horsepower cars, but there's a few expensive high horsepower cars that just lie out by themselves there. So you can study this plot for a long time. You know, there's lots of information here, as you can see. This is a multi-view plot, I call it, because there's just a lot going on there. And so that's one way to do it. Another thing we can do here is, this is similar to what I've been showing you, but we can create a plot. So in this case, remember I did this before where we have the axes and the figures, and this is going to create a 2 by 2 array of axes on a 12 by 12 sized figure. Okay, I hope that's clear. And I have to define what the X columns are and the Y columns. And I'm just going to, actually I want the unique values. And then I'm going to enumerate over those unique values because I'm going to subset the data and plot the histograms. So hopefully that's not too much cryptic code. And this is kind of, so you can see I've got the histogram of price with aspiration equals standard and fuel type equals gas. So I've subset it. It's, you know, basically I've done a manual kind of group by just using the subsetting capabilities in pandas here. So I've got two conditions with an and in the middle, right? And that's how I subset. And then I plot the histogram. See, .plot.hist of that subset. And and then this one down here is aspiration equals turbo, fuel type equals diesel. Notice there's not, the main thing you can come away from that is, notice there's very few of these, and they're pretty much just uniformly distributed. There isn't, the only one with a clear distribution is this first one, where they're all sort of bunched up at the low end of price. So all our it looks like our low cost cars are all gasoline, standard aspiration cars. That's kind of the takeaway message there. Now I can do another thing with Seaborn, which is very cool, and this is what the sort of the key thing that Cleveland book had. I can create what's called a facet grid, and a facet grid is I've done this manually. This is a way to do it. So I'm creating a group by variable here for the columns called drive wheels. And I'm going to do an XY plot of engine size and price using the reg. So I have to say what my plot method is here. And I'm not going to show the regression line. I could do that if I remove that. But so I just get 3 scatter plots, and you see it says drive wheels equals rear wheel drive wheels equals front wheel drive wheels equals 4-wheel drive. And I got price versus engine size. So side by side here, I can look at the price engine size relationship of cars by what type of drive wheels they have. And I can extend that now here. So here I do columns or drive wheels and rows or body style. So this starts to show you the real magic here. I hope. So now I've got 4-dimensional plot because I've got price and engine size on each of these plots, and then I've got body style going down and drive wheels going across. So I've got, I think, 15 little scatter plots that I've subset my data into, and I can start trying to study it. Notice some of these may be empty, like there's no 4-wheel drive hard tops, for example. There's just no data there, so it just shows a blank grid. Or there's just one 4-wheel drive hatchback, for example. But so this is a small data set. If you had a large data set, you might see a lot more. But we only have 195 cars in this data set. But I hope you guys are seeing how this is pulling out 4 dimensions onto a single 2D plot surface now. And then I'm going to do one more thing. I'm going to add an aesthetic, which is fuel type, to my grid, you see. And now we can see, occasionally here, we see where there's diesels. So, all right. So here's your last exercise, and we're kind of at the end of our time, but we can take a couple minutes here while we pack up. So give that a try. Change the X variable to city miles per gallon. And so you're just going to change that facet grid definition and see how far you get. Did I hit it? No, I guess it's running. Is the kernel running? So again, if you have trouble, let us know. Uh-oh. What did I do?
Instead of the point C.
Oh, I copied the wrong thing here. Yeah. Oh, yeah, you're right. Yeah, thanks. Our, I sometimes get, what do you call it, language schizophrenia, because the U Washington data science program, we've standardized on R. Not that it's better or worse than Python, it's just you have to standardize on something. So some days of the week I'm in the Python world and some days in the R world. So you can see, anyway, if you do this, you see you get this pretty complicated plot that you can scan and study and try to figure out, you know, some interesting, cool stuff. Actually, I'm doing a violin plot. That isn't quite what I want it to have anyway. Okay.
Looks good though.
Yeah, that's cool, but that's not the point of the exercise. I must have cut and pasted the wrong thing. Let me try that again. Well, if you have any questions, let us know. Thanks everyone for attending. I hope that was worth your 90 minutes. And there's lots more cool stuff coming. There's another whole set of tutorials after this in 3 different rooms. And there's 2 days of great talks coming up. Thanks. And thanks to Ronald, who's helped me a lot. Hey, Ronald.